Well, hello, welcome back. I'm Colin Archibald. We're doing a review of Java. This is Java for someone who already knows Java. And I have a cold today. That's why my voice is like this, but don't worry, you cannot catch a cold from watching a video. So this time we are going to I had said we're going to do the control structures, but we're not yet. We're going to do operators. So I'm going to comment out all of this code that we played with the last time. I did that by hitting Control / Control / will comment out the selected lines of code. Okay, so operators. Let's just make a summary of the operators that are in the language. The arithmetic operators are plus, minus, multiply, divide, and modulus, and you're thinking, oh my gosh, he's going all the way back there. There are things about the operators that you don't know. I'll bet you a dime. Greater than, less than, greater than or equal to, less than or equal to, and not equal to. Those are the relationals. Those, of course, are the arithmetic. Let's do it in this order. And, or, and not. Those are the logicals, logical operators. There are a few operators in Java that are very, very obscure. So I might tell you that there is a hat operator, which is exclusive OR, that almost no one ever uses. There's really very little use. It is a logical operator. I'm going to put it up here. The reason that I put it there, even though people don't use it very much, is because people think that this operator is the exponent operator. See, I used it up here as if it were an exponent operator, but it isn't. In Java, it is exclusive OR. There are some bitwise operators. That's shift, whoops, and that's shift. There is a tilde operator, which is a complement operator. So these are when you want to manipulate bits inside of an int or a long, you can shift the bits and you can turn them on and off with using these operators, and they are also used very, very rarely. I'm including them for completeness, and if you ever need to manipulate bits in Java, you probably shouldn't be using Java, but in case you are, you can figure out how to use the bitwise operators. Oh, just a second, there's two more in here. There is a bitwise and there's a bitwise OR. So the same symbol is used for different things. So if you have an int and an int, I don't want to go down this path too far. What is 15 and let's see, 15 and 6, probably should be 6, but we're demonstrating here that the AND operator compiles when its operands are integers, ints. So that is a bitwise and it is combining. That is a bitwise OR. It's combining the bits within those to int values. Because that's so obscure, I felt the need to prove that it is in there. What other operators do we have in the language? Well, we have some shortcut operators, increment and decrement, and those come in two flavors, pre and post increment and decrement. And we have the combined assignment operators, plus gets, minus gets, multiply gets, modulus gets, divide gets, and plus gets and minus gets are used frequently, the others somewhat less often. And it's odd that there's even some of these. There's a shift gets, but that's even more obscure. You probably would not use shift gets ever, but it's in there for completeness, I suppose. Unary, positive, unary plus and minus. The unary plus operator is in the language and it does nothing. It does nothing. Not S-O-P-Y. S-Y-S-O. S-Y-S-O. What does plus 56 do? The plus operator does not change the value either of a constant or of a variable. We have let's use the int. The plus operator there is in the language and it does nothing. The minus operator is in the language and it does something. It does change the sign of whatever is in I. So if I had been a negative, then the unary minus operator will change the negative to the positive. So the minus operator does change the sign, and the plus operator, the unary plus, does nothing. Well, there are a few other operators. A cast operator is where you want to change the data type of a variable or even a literal from one type to another. So we write it like this with type inside of parentheses. That will never compile. You actually put a type there. So here's an int cast operator. Let's make these work a little bit and talk about also mixed type expressions. So we started out with the easiest one first, and I'm going to just comment that one out. Let's declare a few variables that we will use to talk about these operators. These are horrible names. Correctly spelled English words are a good way of naming variables. This is only for the purpose of declaring these is only for the purpose of demonstration. So you can't have variables by the same name. As you saw there, I already had a b declared as a byte, and that's a problem. In Java, you declare your variables wherever you want them. So if your code, all of a sudden you decide you need a variable, you just declare it there. In other languages, you have to declare all the variables at the top, but in Java, you declare them near to where you're using them. And then it's very easy for the reader of the code to look and see what data type it is. So from the declaration. Well, I'm not going to go through all of these, only things that are interesting. When you declare a variable and you don't put anything in it, you can't use it. Its state may not have been initialized. Sometimes the compiler isn't smart enough to know that you really did initialize it, and you have to initialize it whether you want to or not. So you cannot use a variable that the compiler is not sure has a value in it. So we cannot print out the value in this variable until we put something in it. So let's put something in it. Let's put C gets A divided by B. So here's the interesting thing about operators. We talked about things having data types. So variables have data types. Literals have data types. This is an int. This is also an int, but in binary in Java 7. This is a float. This is a double. So constants have data types. Operators also have data types. Every one of them has a data type. And in Java, an operator cannot work on unlike data types. An operator has a data type, and it has the data type of its operands. So the data type of this division is int because we have A divided by B. The result of this expression must be that data type. The assignment has a data type, and it's the data type of the value going across the assignment. So whatever this evaluates to, that data type is the data type of the assignment. Let me be more correct. Both operands of that operator must be of the same data type. In this case, it's easy because everything here is in int. So we have an int division, then we have an int assignment. And what is 10 divided by 6? 10 divided by 6 does not have a decimal point in it because everything in this expression is integer. There is never a decimal point in an int or an int calculation, and it is always a truncation, never a rounding. So you don't do rounding in arithmetic operators unless you explicitly say you want to do a rounding by calling a method. This won't compile. You cannot do a downward conversion. You cannot do a downward conversion implicitly. So 1.5 is a literal constant. It has a data type. You know what data type it is. It's a double. It cannot be downcast to an int. But if you want to, you can downcast it yourself. Even anything that's on the right of a cast, whether it's a literal constant or not, can be downcast. This one is kind of ridiculous. We're downcasting 1.5 to an int. It works, but if I wanted an int there, why didn't I just put an int? So what is the integer part of 1.9? Keep running this to make sure that you're still sane. The integer part of 1.9 is 1. Let's look at a mixed type expression. Here's a variable also with a very poor name, d2 gets a. And I'm going to print out d2. So here's a mixed type expression where an integer is assigned to a double, and that's allowed because this is an upcast. How do you know when you're using all of these different data types whether it's an upcast or a downcast? Well, you know because you memorize the order here. So this is the promotion order. A float and a double, we will upcast the float to a double. A long and a float will upcast a long to a float. A short and a float, that's an interesting one. Let's talk about arithmetic operators using byte and short. And I'm going to delay that one until I finish what I started up here. Let's do some more, just a couple more mixed type expressions. So this looks like, well, it's all in double, right? And it isn't. The data type of the operator is decided at the time the operator is executed. A divided by B. When that's executed, the data type of the operator is int. So we would have this 10 divided by 6 is 1, and then we've got an int assigned to a double. What is the data type of the assignment? That would be a double. So we implicitly promote this to a 1.0 and assign it to D2. So what gets printed here is 1.0. The information was already lost. The data type of the operator is decided when the operator is executed. Okay, what is the data type of the divide operator? Well, we just said it's int, but this time it isn't. 1.0 times a. This is a double times an int. Promote the int to a double, and we have 10.0. Then do the division. The data type of the division is now in double. So there's a promotion or an upcast implicitly. There's one here, we promote the a so that the multiply can happen, and then there's one here, we promote the b so that the divide can happen. Remember that an operator in Java only works with like data types. These data types are unlike, but Java will fix it by promoting to the same data type. And we will always promote to the larger, knowing that this is the order. Byte short int long float double. Let's prove what happened here. So 10 divided by 6 in double, and we have this result. Probably multiplying by 1.0 is not the best way of promoting an int to a double, because we have this handy cast operator. A cast operator has a very high precedence, so it will happen before the divide. It grabs onto what's on its right, and it will upcast the a to a double, and then do the divide, and we get the division done in double, the result in double. Here's the takeaway. An operator in Java only works on like data types. It doesn't matter what the operator is. The data types byte and short in Java do not have arithmetic operators defined for them. Well, what does that mean? Whoops. Okay, so I'm going to write B1 plus B2. It's the simplest possible thing in the world. B3. And it doesn't compile. And it doesn't compile not for the reason that you think. B1 plus B2, we want to add 12 and 5. We want to get 17. It'll fit in a byte. But there is no addition operator for bytes or shorts. So when you write B1 plus B2, Java promotes both of these to int so that it can do the addition in int. So 12 plus 5 is 17 in int data type. It won't fit in a byte, so it won't compile. And this one is a little bit tricky. People don't recognize that there are no operators defined for byte and short. So here's one of the options. What they suggest is to cast the result of the addition down to a byte. And you can do that. This looks a little bit strange. We add 2 bytes together and then we downcast the result to a byte. It feels uncomfortable, but you have to know that the addition happened in int, not in byte, because there is no addition in byte. The same rule is true for short. There are 4 different addition operators. There are 4 different multiply operators. They all use the same symbol, but they're all doing something different internally. If you do a division in float, that is different from doing a division in double. So there are 4, but there are not 6. There are no arithmetic operators defined for these 2 types. There's nothing particularly difficult that I can think of about the relational operators. Relational operators evaluate to a Boolean all the time. There is no equivalence of numeric types and Boolean types. If you print out a Boolean, it will print out the literal constant true or the literal constant false. There is no Boolean cast operator. You cannot cast an int to a Boolean. You cannot cast anything to a Boolean. And nothing can be promoted to a Boolean, and a Boolean cannot be promoted to anything else. So the cast operators, there is a cast for every data type except for the Boolean data type. Oh, let me make sure that that is true. Yes, there is a cast operator for each of the primitives except Boolean. It doesn't play with anybody else. The shortcut operators. Let's talk about the shortcut operators for a second. And the combined assignment operator. The most common one is plus gets. And if you write, how about C gets C plus 10. If you ever write this in your code, someone will say, hey, that's a beginner, because you should have written C plus gets 10. So when you have the opportunity to use the combined assignment operators, you should use them. There's a tricky one. Go back to this. Let's take B1 gets B1 plus B2. And this doesn't compile for the reason we talked about before. There is no plus defined for bytes. The shortcut operators, which usually help you, in this case might confuse you. So this shouldn't compile, right? Because B1 plus B2 is an int and we cannot assign that to a byte. But this one does compile and it does run. So when we expand this and we get C plus 10, it's not exactly what happens. We don't get B1 gets B1 plus B2. What we do get is B1 plus B2 downcast to a byte. So every one of these compound assignment operators has a cast operator, and the cast data type is the data type of the receiving variable. So this one would lead you to believe that we did add 2 bytes together, but we didn't. We added 2 ints together and downcast the result to a byte. These tiny, tiny little issues are what makes you confident when you're writing Java code that everything that can possibly happen, you're ready for it. And you might think, well, why am I into this nitty-gritty? It's a confidence issue. Anything that can happen, you will not be surprised by it. Let's look at the logicals, and in particular, the 1 keystroke logical operator and the 2 keystroke logical operators. So we have a Boolean variable kicking around that we can reuse. Result true is a literal constant. True and true. Let's take that and put it there. So true and true is true, and it makes no logical difference if you use the 1 keystroke or the 2 keystrokes. Whatever this evaluates to logically is going to be the same whether it's the ampersand or the double ampersand. So when does it make a difference? Let's use something really simple. Let's put false and increment A is greater than 10, greater than Okay, so we're going to print out 2 things. Well, false is false. We know that. False and anything is false. So here's the question. Did we increment A by 1? So we put 10 into A. We evaluated this expression. We stopped here. We didn't do the right-hand side of the and that means that the side effect of evaluating this expression, the side effect was that A was incremented, but we didn't do it. And we didn't do it because we used the two keystroke operator, which says once you know the result, you don't have to do the right-hand side. The difference between the two keystroke operator and the one keystroke operator is that with this operator, the single ampersand, we will evaluate the right-hand side, including the side effects. The side effects are things that change while evaluating the veracity or the truthiness of this expression. So the single ampersand will evaluate both sides all the time. The double ampersand evaluates the right-hand side only when it has to. If you have true on the left of an and, we don't know the answer yet. True and, it still could be true or false, so we're going to go and evaluate this side, and that means that the side effects will happen. If we have false on the left, we know the answer. We know that the whole thing is false, and we will not go and evaluate the right-hand side. The operators in Java, all of the tricky little things that I could think of. Well, there might be a couple more with the logical not. So we have a result okay, not true and false. Which happens first? In general, the unary operators, that means operators that have only one operand, have the highest precedence. So a cast operator is a very high precedence operator. A not operator is very high precedence. What's not true and true? Well, it's going to be false, but what the order of things is that this happens first. Let's try 10 is greater than 34. This doesn't compile because this operator tries to happen first. The not operator only works on a Boolean operand. Not 10 will not compile. The operator not is undefined for the argument type int. So let's force that to happen first with the parentheses. So now 10 is greater than 34. That's false. Not false is true. True and true is true. So the not operator almost always is followed by something in parentheses, but it always is followed by a Boolean or something that evaluates to a Boolean. So it might be a Boolean variable. That would be confusing if we printed out not result. The opposite, the logical opposite. So if you have an expression that evaluates to a Boolean, you can put a not in front of it. All of the operators in Java, including these obscure ones that we're probably never going to use, the bitwise ones, the combined assignments, which have one trick that make you think that you're doing arithmetic with bytes or shorts, but you're not. Okay, so this was the operators in Java, the primitive operators. Let's go and review all of the primitive control structures. So I said that the last time, but I really mean it this time. We're going to go and look at the control structures, the if statements and the while loops and so on. Hello and welcome to this review of Java. Let me tell you first of all what my expectations are for this video segment. I'm not going to teach Java from the beginning. We're going to go back to the beginning and review. So this isn't the place to learn Java if you're in an introductory Java class. If you're in one of my more advanced Java classes, this is the right place to be. Okay, let's go back to the very beginning. You're going to be using Eclipse, and this isn't an option. You're not be using JGrasp or NetBeans or any of these other ones. We're going to use Eclipse. Here's where you get Eclipse, eclipse.org. You should get the most current version of Eclipse that is called Eclipse IDE for Java developers. This has a Java compiler built into it. You don't need to do anything else. Just go and get the appropriate one for you. You have to know if your machine is a 32-bit machine or a 64-bit machine. Hopefully you know that, and hopefully you know if you're using a Macintosh. If you are, then there's a different version of Eclipse. Everybody should be using the most current version of Eclipse. And if you're going to work on a team, so if you're going to share a code and work on a team, then it's important that you put your Eclipse in the same place. Okay, so here is the C drive on this machine. When you unpack Eclipse, put it on the C drive. Don't put Eclipse in someplace that's a very, very long path. Eventually something will break because your path to a file is too long. So do it the easy way on yourself. Don't make it complicated. And if you have lots of different ones, so you can see that I have an Eclipse with no identifier on it. Now I have an Indigo SR2 and a Junel all on here at the same time. It's really better if you only use one at a time, and it's essential that you only have one open at a time. So if you have two different Eclipses open at the same time, you're asking for trouble. They will be confused. If you're working with other people, use the same version of Eclipse as you pass stuff back and forth to each other. You don't want to have to start from the beginning every time. So use the same version of Eclipse. And if you're starting out a class now, get the most recent version of Eclipse. As of this date, it's Junel. In your semester, it might be something newer. It might be the H1 or the HIJ. These are in order. It was Helios, Indigo, Juno. There'll be a K and an L. So the most current one, identified by the first letter of the name of the version of Eclipse. Okay, so I'm in Eclipse Juno right now, and I'm going to make a new Java project. I'm just going to call it review. And in the source folder, I'm right-clicking and I'm going to say make a new class. I'm going to add the main method to it because I'm too lazy to type it. So here is review stuff. Not a very good name for a class, is it? Let's go back to the very beginning of Java. Even if you are a good Java programmer, there is stuff in here that you don't know. I will wager $1. There is stuff in here you don't know. So the very beginning, the lowest of the primitive parts of the language. Let's start there. There are 8 primitive data types: byte, short, int, long. Those are the integer data types. Please don't declare a variable L. No one will work with you. An L, a capital I, float, double. Those are the 2 floating point data types if your numeric value requires a decimal point. There are 2 more primitive data types: Boolean and char. So there is a declaration of each of one of each of the 8 primitive data types. This one takes 1 byte of storage. How many bytes in a byte? Well, there is 1 byte in a byte. And if you can remember that, then there are 1, 2, 4, and 8. So the values that can fit in these are dependent on how much space you have, so you have to know that there is 1, 2, 4, and 8 bytes of space available. In a float, there is 4 bytes of space available, and in a double, there is 8 bytes of space available. In a char, this is different from the C language, there are 2 bytes of space available. People don't talk about how much space a Boolean takes, but we can say that a Boolean takes 1 byte of space. And people don't talk about it because there isn't an issue of how big is the Boolean you can put in there. A Boolean is either true or false, and it can be stored in 1 bit, but we don't have access to a bit. You have to know the order of these. So byte, short, int, long, float, double is the promotion order of the primitive data types, and you must know the order because when you use mixed type expressions, there's going to be automatic promotions, and you have to know what gets promoted to what. So here's something that one of my students once made up. Beef stew is like food and drink. There are the first letter of each of those 6 data types in this little rhyming thing. It doesn't rhyme. I forget what this is called when you make up something for your memory. Let's see. So those are the 8 primitive data types in Java. There aren't going to be any more. That's all there are. And notice that every keyword in Java is all lowercase letters. That's true throughout the language. So public, static, void, these are keywords in the language, public, class, and the names of the primitives. Main is not a keyword in the language, it's an identifier. This is an identifier that we made up. String is not a primitive in the language, it's the name of a class. It starts with a capital letter. This is an identifier. It can be anything you want it to be. It's your identifier. The data type is not yours. You have to use an array of strings there. but the name of the parameter on the main is up to you. Okay, so the primitive data types, let's look now at the literal constants in the language. So these variables that I declared with very poor names have a data type. So B is of data type byte, F is of data type float, and so on. That's kind of obvious. But it's less obvious that everything in Java has a data type. Almost everything. So if you write a literal constant in the language, 1, 2, 3, 4, a literal constant is a value that isn't a variable, it's a value that you write in the code. All of them have a data type. If it's a number without a decimal point, then its data type is an int. If it is a number without a decimal point, but it's bigger than what would fit in an int, then you must put a suffix on here that indicates that it's a long. So this is a long literal constant. It ends in an L. If you put a lowercase l there, it will work, but no one will work with you. So an uppercase L. So there's an int literal constant and a long literal constant. Let's look at a byte literal constant. Sorry, we have one called B. A byte literal constant. It looks very much like an int. And in fact it is, but because it's a constant, Java can tell if it will fit in a byte. 127 will fit in a byte, so it takes this int constant and narrows it from 4 bytes of space to 1 byte of space. This is the only place in the language where a narrowing will happen for you. That's key. This is the only place in the language where a narrowing or a downcast will happen for you. In all other cases, a narrowing has to be explicit. So why can it do this? It can do this because it's a literal constant and it knows that 128 will not fit. Cannot convert from int to byte, but with 127 it can convert from int to byte because 127 will fit in 1 byte and 128 will not. And that's because a byte is a signed. All of the numeric data types in Java are signed. That means one of the bits is used as the sign bit. So in a byte, we can store the values minus 128 through positive 127. And that is the range of 2 to the power of 7 minus 2 to the power of 7 through 2 to the power of 7 minus 1. Each of these, the range of values that can store in them is calculated in the same way. If you have 63 data bits in a long, 8 8s are 64, and 1 sign bit means you have 63 data bits, minus 2 to the power of 63 through 2 to the power of 63 minus 1. I don't know what those are when you multiply them out, but I know that that is exactly the largest value that can go in a long variable. If I had a calculator and I needed to know, I could pretty soon find the answer. Let's go back to our literal constant discussions. Here's a short variable. The same thing happens as with the byte. Let's see. I wonder if I can remember this. 32,565 will fit. Oh, I've done something wrong here. I was trying to remember exactly the largest value that could fit in 15 bits of space. 2 to the power of 15. Well, if it's too big, it will not narrow, cannot convert from int to short, and because it's a literal constant, it knows. So there's an exercise for the reader. Find out exactly what the largest value is that will fit in a short, and it is 2 to the power of 15 minus 1. I just don't know what that is right now. So those are literal constants of the integer type. Let's look at literal constants in floating point. So here's 2.5, and it doesn't compile. So a number with a decimal point in it is a double, and you cannot convert a double to a float. It will not downcast for you. So a literal constant that fits in 4 bytes of space, that is a floating point number, has an f at the end of it. So there's a float literal constant. And here is what we just did before, a double literal constant. This one is easy. There are 2 literal constants that are of type Boolean. You write them in all lowercase letters, true and false. And to write a literal constant, whoops, we have a character variable. There is a literal constant character inside of single quotes, just one of them, or it won't compile. You cannot put more than one character inside of a literal constant. A few special ones. In an integer literal constant, you can put a hex number, 0, 1, 3. Okay, if your literal integer constant starts with a 0, this is not the number decimal 13. This is an octal number, base 8. So that's one group of 8 and 3 groups of 1. And if we print out this value, we will print out 11, not 13. Let's make sure that things are running here. Okay, so there it is. The number is 11. So a leading 0, it's not an O. A leading 0 means that it's an octal number. Why doesn't this compile? Well, this message is not as helpful as most of them are. An 8 is not a valid digit in an octal number. There is no digit 8 in an octal number. There is a 7. That is not the number 17. Here's another one. 0x A04. Okay, so this is an integer literal constant, an int literal constant, and it is a hex number. So the prefix 0x means that this is a hex literal constant. What is A04? I don't know. 2564. So a hex number, the ones place, the 16s place, the 256's place. So that's 10 256's plus 4. 10 256's is 2560 plus 4 is 2564. So you can represent int constants as hex or octal numbers. In Java 7, you can write a binary constant. This is new in Java 7. And you can tell if you are using, if you're using Java 7, if this compiles. So 0b is a prefix for a binary number. So 1001, what is that? 9, I think. Okay, so that is an int. Its data type is int. It's a literal constant, but its radix is binary. Okay, so literal constants. Let's do some in floating point. How about 1.5 e to the 6. So this is a double. This is 1.5 times 10 to the power of 6. Let's print it out. SYSO, control space, is an easy way of doing a system out print line. SYSO control space. Okay, so here's 1.5 times 10 to the power of 6. So this scientific notation is quite easy to write a literal constant. And you can use a capital E there if you want to. It doesn't matter. This can be a negative number if you want to. And this can be a negative number if you want to. Oh, and it actually prints out the, instead of putting all of the, it writes it out in scientific notation. I'm a little bit surprised by that. I didn't know that the print line would choose to do that. Interesting. So it is a floating point literal constant in scientific notation. If we put an F there, it won't compile because it's a double. So its data type is double. And how will we make it? You already know the answer to that. We'll make it a float. So this is about the most complex literal constant that there is in all of Java, because it has 2 letters in it and it can have 2 negative signs in it. Let's print out the F. Make sure that that's working. See, I said everyone would learn something from this, and I didn't know I was including myself. I didn't know that if that was a negative in the exponent, that it would print out the result in scientific notation. So I did learn something here. There it is. Right from the beginning, have great confidence that what you're doing is everything that can be done, and it is the right way of doing things in Java. Okay, we're at already 20 minutes or so of doing this, but I'm going to keep going. Let's talk about valid variable names. First of all, what is legal in a Java variable name? You can use underscores, and you can use digits. All of this is legal. You can use underscores at the beginning of a variable name. All of this is legal. You can use $signs. You can use $signs at the beginning. You can't use any other special characters. So this is compiling. This is a valid integer variable name. Well, it is a valid Java identifier, and we can assign that to some integer value. But you can guess that, yep, no one will work with you if you name your variables like this. Oh, there is one more. You can put capital letters. in your identifiers. So uppercase, lowercase, underscore, $, and digits. Those are all of the characters that you can use in an identifier when you're making up your identifiers. That might be a class name, a variable name, a method name. You cannot start with a digit. It won't compile. Okay, so now that you have what you can do, here's what you should do. For a variable name, using camel case, all variables in Java start with a lowercase letter. This is the convention. Correctly spelled English words, separated not by underscores but by capital letters. So that's camel case. And I expect everyone to do this all the time. So correctly spelled English words, if you make up variable names and no one can figure out what they might be used for, that's a bad thing. Don't do it. Correctly spelled English words in camel case. If you have a constant, that means because it's modified by final, this is not a variable. It has it cannot be changed. Use all uppercase, and for readability, the underscore. So this is the format for a variable, and this is the format for a constant. You might be wondering, why do they allow $signs if they then tell you don't ever use one? There are times when Java itself has to make up an identifier at runtime. You probably don't know exactly when, but if it has to make up an identifier at runtime, it will put a $sign in the identifier that it creates. And there can be no identifier by that name already, or you would have a runtime error. So we have now the requirement that the $sign is a valid character in an identifier, but you as the programmer don't ever use one. So a couple more things about choosing your identifiers in Java. The name of a class and the name of an interface always start with a capital letter, always. The name of a method in Java always starts with a lowercase letter. So the rules for naming a method are pretty much the same as the rules for naming a variable. A method name has a verb in it almost all the time. Main doesn't, but I would hope that almost every method does something. And what it does should be the verb in the method name. It should only do one thing. That makes it easier to pick the verb. If you create a method that does 8 things, then it's hard to pick the name for that method. Okay, so what have we done in this video? Every possible literal constant in the primitive data types, all of the primitive data types, the naming conventions, the legalities of naming, and the conventions of naming, including the declaration and naming of a constant. Okay, that's enough for this one. Let's go and do another review with all of the details of the primitive control structures in Java.